Welcome to ExamApp. An 8 kilogram bowling ball rolls down a steep hill from a height of 11.25 meters. Taking g as 10 newtons per kilogram, calculate the velocity of the ball as it reaches the bottom of the hill. This question has two parts. We first need to calculate the gravitational potential energy of the bowling ball as it begins to roll down from the top of the hill. We are then going to assume that all of the gravitational potential energy gets converted into kinetic energy. From there we can work out the final velocity of the bowling ball. Let's start off by working out the gravitational potential energy of the bowling ball at the top of the hill. Gravitational potential energy is equal to the mass multiplied by the gravitational field strength multiplied by the height. So that would be 8 multiplied by 10 multiplied by 11.25. This gives us a total gravitational potential energy of 900 joules. Assuming this is completely converted into kinetic energy, we can now look at the equation for kinetic energy, which is a half multiplied by the mass multiplied by the velocity squared. So 900 is equal to 1/2 multiplied by 8 multiplied by velocity squared. So that's 900 is equal to 4 times the velocity squared. If we divide both sides of the equation by 4, we see that 225 is equal to the velocity squared. Square rooting both sides of this equation gives us 15 meters per second as the final velocity of the bowling ball. We have assumed that all of the gravitational potential energy is converted into kinetic energy. In practice, this is rarely ever the case. Therefore, we would actually expect the final velocity of the bowling ball to be significantly less than 15 meters per second. Find more tutorials, revision and quizzes at examapp.co.uk.